How does Catalyst prepare students for the extended experimental investigation?
Well, as we mentioned already, the extended experimental investigation is the first classroom-based assessment that the students will have to do in second year. And students' work will be judged on level descriptors against features of quality in the areas of investigating, communicating, knowledge and understanding. So it would be good practice to ensure students are made familiar with these features of quality from an early stage so that they know what is expected of them from the extended experimental investigation. And if you look at the features of quality for the extended experimental investigation and compare them to the approach taken in Catalyst towards students' work, you will see that the way we have advocated the development of understanding and skills throughout the book will certainly put students on the right track for both of the classroom-based assessments. So if we just take a look at those four areas in more detail, and we'll start with investigating. So, for example, features of quality linked to exceptional work would show students forming a testable hypothesis or prediction with justification. And in Catalyst, there are a multitude of activities where students are invited to form their own hypothesis, and it is an integral part of the approach to documenting the scientific investigations in their portfolio. In the area of communicating, students will be asked to present data in the most appropriate way using relevant scientific terminology and informative representations. Many activities, investigations in Catalyst will help to develop students' skills in presenting and analysing data, and the numeracy moments in particular that are embedded throughout the book have a number of calculation challenges. Another feature of quality is that students show creativity in presentation or use an innovative approach, and in Catalyst as well it is full of innovative ways of communicating science in a way that is engaging and modern, such as blog entries, videos, posters. In the areas of knowledge and understanding, students will be asked to describe in detail the strengths and weaknesses of their own investigations, include appropriate improvements or refinements, and explain fully why no further improvements could be reasonably achieved. A central point in our portfolio booklet for all of our scientific investigations is that there is an evaluation section for all of the investigations that they would do. So when a student starts the extended experimental investigation at the end of second year, there are 4 phases to this particular investigation, and Catalyst more than supports students in being ready to fully engage with these 4 phases. So the 4 phases are questioning and predicting, planning and conducting, processing and analysing, and then the final phase is reflecting and reporting. So if we take a look at the first phase, which is questioning and predicting, this is where students will choose their topic, consider a research question, and then form a hypothesis. The second phase, which is planning and conducting, this is where they will plan and conduct their investigation. So in the third phase then, which is processing and analysing, this is where students work individually to analyse their own data, to perform any necessary calculations and so on. And the fourth and final stage is reflecting and reporting. And in this phase, students discuss various aspects of their investigation, such as experiment design, possible improvements, limitations of the data that they've collected, and any possible theoretical and practical implications of their work. So we really believe that Catalyst has the correct approach to not only inform, develop and get students ready, but also to be successful in the extended experimental investigation.